Welcome back to All This Math. This is Professor Parker, and today we're going to do some math fundamentals. We're going to do some subtraction with mixed numbers where we have to borrow, also known as regrouping. We have to regroup. So I'm going to get into that. I'm going to give you a step-by-step process on how to do that whenever you see a problem that looks like that, and hopefully you'll recognize how to do it. But before we get into that, I do want to talk about, I want to mention and shout out Central State University. Central State University is an HBCU located in Wilberforce, Ohio. It's actually adjoined with Wilberforce University, which is a historically black college and university where W.E.B. Du Bois at one point was an instructor there, was a professor, before leaving there and coming to Philadelphia, where I currently live, actually, where he did his research, which led to him publishing the Philadelphia Negro. This is about the end of the 19th century, like around 1898-ish, when all that happened. I think he was teaching at Wilberforce in 1896, I want to say. You know what I'm saying? He also had the opportunity to go teach at Tuskegee down in Alabama. Booker T. Washington extended him an offer to be a math professor down at Tuskegee, but he had already accepted the position at Wilberforce. And this is connected because it's right next door to Central State University. And if I'm not mistaken, Central State University was actually part of Wilberforce or something like that. I gotta do my research on that to confirm that. But when I think of Central State and I think of Wilberforce, I also think of another brother who should be much more popular and in more of our conversations in our community, who is Martin Robeson Delaney, or Martin Robinson Delaney, because Martin Delaney is actually buried in Ohio, not too far, in a cemetery not too far from those universities or those colleges. I got a couple of his books that I want to point out to you. This is one of his books. This is the Condition, Elevation, Immigration, and Destiny of the Colored People of the United States, and Official Report of the Niger Valley Exploring Party. This is one of his books that he authored. All right. This is a biographical text written about him by Dorothy Sterling. All right. The Making of an Afro-American, Martin Robeson Delaney, 1812 to 1885. The story of the father of black nationalism. Some people refer to him that way, as the father of black nationalism. Then we have another text. Gotta be careful with this one. See, my dust jacket's all messed up. But by Victor Willman, Martin R. Delaney, The Beginnings of Black Nationalism. The Beginnings of Black Nationalism. All right. And then we have a shorter text written by Delaney, The Origin of Races and Color. The Origin of Races and Colors. It's a little thin, quick read. And this is a text I need to finish. This is a fictional novel that he wrote called Blake or the Huts of America. All right, Blake or the Huts of America. So this is just some writing by Delaney and also some biographical writing about Delaney. So definitely, if you never heard of Martin Delaney, go check the brother out, do some research, grab some of the books from a black-owned bookstore, hopefully, and go down that rabbit hole. Just learn about Martin Robeson Delaney. I'm telling you, he's a very impressive figure. He's a good person for your children and your young people to do school reports on. All right, especially if they never heard of him. Okay, so check him out. Now, for our math lesson, we're doing some subtraction with mixed numbers. First of all, what is a mixed number and why are they called mixed numbers? We need to first understand that. Mixed numbers are numbers that consist of two different types of numbers. So you have a whole number part and you have a fraction part. A whole number part and a fraction part mixed together, which creates a mixed number. So here we have 3 and 5/9. 3 is the whole number part and 5/9 is the fraction part. Then we have 2 and 7/9. 2 is the whole number part. 7/9 is the fraction part. So that's why we call it a mixed number. Every time we deal with anything in mathematics, we should understand, why is it called that? Why does it even have that name? Why does that make sense? And most of the things, if not all, well, at least most of them, most of the things and a lot of the things in mathematics, their terms and terminology we use to describe them actually make sense. When you think about it, you think about the definitions of the terms that are used to describe them. So now with subtraction, all right, so we have this many of an object, we have 3, and then we have a portion of another object, not a whole object. That's why we have a fraction, right? And we're going to subtract from that 2 whole objects and a portion of one of these objects, right? 7/9 of it. So first, let's talk about this conceptually. Like, what does this mean? What does 5/9 mean? All right. So 5/9 means that we have a whole object. Object could be a slice of cake, a pizza, a group of people, I don't know, a book, right? Whatever it is, the denominator, which is the bottom number, 9, 9, 9, 9, the bottom number is called the denominator, right? The denominator. You probably already know that though, but the bottom number is called the denominator. Denominator, all right? The denominator tells you how many equal pieces we can divide that object up into, whether it's a group of people, whether it is a pizza, whether it's a cake, whether it's a book. You know, a book has a certain amount of pages in it. If you take one of Martin Delaney's books, let's say Blake, this book right here, right? We look at all the pages and we say, you know what, we're going to divide this book up into 9 equal parts. All right. So each equal part is 1/9, right? And then you start doing some reading, put the book down, come back to it, do some more reading, put the book down, come back to it, do some more reading. And over time, you realize you've read 5 of those parts. That's what your numerator is. Your numerator basically is how many of those equal parts are you focused on. So if I had a book like this, right? Blake or the Huts of America, right? By Martin Delaney, okay? And I divide this book up in terms of the pages into 9 equal parts or ninths, equal ninths. And then I start reading it and then I realize I've read 5 ninths, right? That's what that means, okay? So now this 3 might mean, okay, I've read 3 of his other books. I read 3 whole books and then I read 5 ninths of this book. So I read 3 whole books by Delaney. Then I read 5 ninths of this book, Blake or the Huts of America. All right. Now, so what does 2 7/9 means? 2 7/9 means I might have read 2 other books from another author. I don't know, maybe 2 books by, let me think. Can't think of another author. But let's just say I read 2 books by another author, and then they had a 3rd book that I also divided the pages up into 9 equal parts. All right, 9 equal parts. But here's another thing. The books would have to have the same total amount of pages in order for me to do this, right? The books would have to have the same total amount of pages in order for me to do this exercise, do the subtraction, all right? Subtraction or addition, all right? So I divide that book up into 9 equal parts, and then let's say I've read 7 of those. So I've read 7 ninths of a 3rd book. So I read 2 whole books. Then the 3rd book, I didn't read the whole book, but I read 7 ninths of it. So after we divided it up into 9 equal parts, I read 7 of those 9 equal parts. That's what 7 ninths means. So I want to make sure you understand what a fraction really means. Like, what does it mean to say 5 ninths? Like, when I was very young, I did not understand what a fraction really meant. I knew how to add fractions, subtract fractions, multiply them, divide them, reduce them, simplify them, but I didn't really know what a fraction meant. I couldn't explain it to you, and nobody asked me. They just, people just cared, teachers cared, standardized tests cared about me knowing how to add, subtract, multiply, divide, reduce, and simplify. That's what they cared about. That's it. But that's not enough. My belief and my fundamental belief is that you should understand not only how to do those things I named, the arithmetic, but also understand conceptually what a fraction actually is and how to describe it and explain it to other people. All right. So what we need to do is now we're going to do some subtraction. All right. Now, when we want to subtract, first we look at our whole numbers. We say, okay, I got a 3 and I got a 2. 3 is larger than 2. So that's cool. When we use this method and the problem is set up like this, we don't want to end up with negative numbers. So therefore, our fractions, when we subtract or add fractions, we never, ever, 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 ever subtract or add the denominators. These never get subtracted or added, these 9s. So we are not about to do 9 minus 9 equals 0. We're not about to do that. We ain't going to do that. All right? But we are going to subtract the numerators. But when we use this method, the top numerator must be larger than the bottom numerator. And in this case, it is not. 5 is less than 7. That poses a problem because we don't want to deal with negative numbers. We don't want that. We don't want negative numbers. All right? So we're going to regroup or borrow. I should write that. Borrow. We could also say borrowing. Regrouping, borrowing, They're synonymous. So now how do I do that? What I do is this, right? I'm going to borrow, in order to make this fraction bigger, right? In order to make this numerator larger than 7, because right now this numerator is less than 7. I need the top numerator to be larger than the bottom numerator. So you should put that in your notes. Your top numerator should be larger than your bottom numerator if you have a problem set up in this manner, vertically like this. It's not like that right now, but we're going to fix it to make it like that. So we're going to borrow from the whole number. We're going to borrow 1 from the whole number. So it's going to look like this. This 3 is going to turn into a 2. And then this is going to become 2, right? Because the 3 turned into a 2. Because I'm taking 1 from the 3. And then I'm going to give it to the 5/9. I'm going to give it to the 5/9. So now I got 2 plus 1 plus 5/9. Right? Right? But this is what I got to do. I got to change this 1 into a fraction. I got to change this 1 into a fraction. Now, this is like the tricky part for a lot of people, right? So I want you to pay careful attention at what I describe next. We got to change this 1 into a fraction. So we need to know a couple things. One thing is, anytime you have a fraction that's equal to 1 or the same thing as 1, the numerator and the denominator must be the same number. Again, anytime you have a fraction that's the same as 1 or equal to 1, that means the numerator and the denominator must be the same number. They must be the same number. All right? Anytime. All right? So 8/8 is equal to 1. 30/30 is equal to 1. 40/40 is equal to 1. 5/5 is equal to 1. 2/2 is equal to 1. Now, why does that make sense? Let's think about 2/2, right? If you have an object, right, and it's the denominator is a 2. So what that means is cut up into 2 equal parts. Your numerator is also a 2. That means you're focused on 2 of those parts. That's the whole thing, because it's only 2 parts altogether. So if you got 2 parts altogether and you're focused on 2 of those parts, that means you're focused on the whole thing. The one whole thing. The one whole thing. Same as if you have an object like a slice of, like a pizza pie, right? Pizza pie typically is cut into 8 slices. If it's a large pizza, you got 8 equal slices. So your denominator is 8. If you have 8 equal slices, your denominator is 8. But if a group of people, right, eat all 8 slices, that means the numerator is 8. If you have a fraction representing how much was eaten, the numerator is 8. So that means the whole pizza was eaten. The one whole pizza was eaten. The one whole pizza was eaten. So that's why the fraction 8/8 or 8/8 is the same thing as 1, as the whole number 1. All right, so keep that in mind. So now I need a fraction that's equivalent to 1, but I also, because I'm doing addition, and whenever I do addition, my denominators must be the same. I must have common denominators. That means my denominators must be the same. So therefore, I need 2 things. I need a fraction that's equivalent to 1. So I know my numerator and my denominator got to be the same number. And because I'm trying to add it to 5/9, I need a denominator of 9. So this is kind of like a puzzle. It's like a game. So don't think it's difficult. Don't think it's hard. Don't think it's like, intimidating. We just got to figure out, so what fraction can I make? I know my denominator's got to be 9. So watch this. I'm going to bring the 2 over. And then I'm going to do my plus sign, put a fraction bar. And then I know my denominator's got to be a 9 because it's got to be the same as this. It's got to be the same as this. So I put a 9 right there. And I also know that my fraction has to have the same numerator as denominator. So if my denominator is 9, I already know my numerator got to be a 9 too, because 9/9 is the same thing as 1, right? Because if you got you got a bag with of candy, right? And you got 9 pieces of candy in the bag, right? That means your denominator is 9 if there are 9 pieces of candy. But if I want a fraction that represents how many pieces I've eaten, if I eat 9 pieces, that means I've eaten the entire bag, the entire 1 bag. So that's 9/9. So there were 9 equal pieces. That's my denominator. And I ate all 9 pieces. What I ate, or what I'm focused on, is my numerator. So that's 9/9. That's the 1 whole bag. So I ate 1 whole bag of candy, right? So that's why 9/9 is the same thing as 1. 9/9 is the same thing as 1. So then we go back, we put the 5/9. And these 2 we can combine. So now we have 2. And we only add the numerators. We don't add the denominators. We only add the numerators. So 9 plus 5 is 14. So I got 14/9. Right? Now that's an improper fraction, but that's okay though. That's okay. We we can have an improper fraction. This is not our final answer. So therefore, we can do something that's kind of inappropriate, which is have an improper fraction inside of a mixed number. We can do that temporarily. So it's kind of like, you know, when Dr. Bobby Wright says, you know, we can compromise on tactics, but we don't compromise on principles. Our math principles are solid. We're adhering to our math principles, but we're compromising on tactics because typically we wouldn't have an improper fraction inside of a mixed number. But that's only temporary. So it's like late Dr. Bobby Wright, Psychopathic Racial Personality. Please read that if you're not familiar with it. Check him out too, right along with Martin Delaney, you know. Because like I said, we can compromise on tactics, but we don't compromise on principles, all right? So now we bring this over, this 2 7/9. So we bring this over, and now we can do the subtraction. Now we can do the subtraction because my top numerator is bigger than my bottom numerator, right? So now, let's do this. Let's subtract the whole numbers first. 2 minus 2 is 0. Because it's 0, we don't have to write it, right? Then 14/9 minus 7/9. So if we have 14/9 and you take away 7/9, how many ninths are you left with? 7, because we know our subtraction facts. 14 minus 7 is 7. So we're left with 7/9. And this is our final answer. And this is a fraction that can't be reduced because the common factor between the two numbers, the numerator and denominator, is 1. So this is our final answer, 7/9. And this is how you subtract mixed numbers when you have to regroup or borrow. But when do you have to do that? When your top numerator is not larger than your bottom numerator. When your top numerator is not larger than your bottom numerator. Now, this is only one way to do it, right? There are other ways to do it without borrowing, right? There are. We would end up with negatives, but we don't want negatives right now. Using this method, we don't want negatives. But that's not to say that you can't ever have a negative, because you can. But that just means you will be using a different method. So keep that in mind. All right. So now this is just one example. Get some more practice, do some more problems, ask your teacher or whomever, or go online, find some worksheets that have example problems like this, where that require you to regroup or borrow. They might use the term regrouping or borrowing, either one. And yeah, but you got to practice though, right? Because I showed you how to do it. And I told you some things to think about as you're doing these problems, but you got to practice. When you practice, you get mastery. You master these problems. When you practice, you get mastery. All right. So just, you know, go get some practice. Do some research on Central State University, Wilberforce University, Martin R. Delaney, Dr. Bobby Wright, and go get some practice. And I'll see you in the next video. Peace.